Alright, first we have to put the pumpkin in the bag.
Okay, why are you weighing the pumpkin?
So we can find the mass of the pumpkin.
Okay.
Come on. And the mass is about 8.5.
Okay, so we gotta change that from pounds to what?
Kilograms.
Kilograms. Okay, Natalie's doing the math for that right now. .85 times .45, we get, what are we getting?
3.825.
Let's call it 3.8, right?
Yeah.
So the mass of the pumpkin is 3.8 kilograms. But
Okay, so what we're gonna do to get the joules of how much our pumpkin will get on the playground, we're gonna do 3.8.
okay, hold it up so it's not sideways.
3.8 times 15 times 9.8
What
equals
was 3.8? That was what?
the mass of the pumpkin.
Right.
And then we're gonna do
That's the 15 from.
the kilograms.
No, 15 is the distance. And what is it? The distance of the pumpkin from the playground, the height of the ladder. 15 what?
Meters.
Okay.
And then times 9.8 equals 558.6 joules.
Okay, so your box that you build has to absorb most of that so that your pumpkin won't burst inside. Okay, and we know that the ladder is about 58 or 50 feet in the air because we measured that the height of the ladder when we did the balloon drop. So we tied knots in the string and then we laid it on the ground. We got 56 feet, so we rounded to 50. So we got 50 feet, turn it into meters. Then we took pounds, turned it to kilograms. Then we took kilograms, meters times 9.8. That gives us the joules. That should work. Okay. Oh, let's go back. Okay, what are we trying to we're going to use physics to explain what, Natalie, here?
Which one's more powerful? Him falling off a cliff or the boulder landing on him?
Okay. Oh, I went too far. Hold on. Okay, this is what we did. We established that maybe this was 10 tons, so maybe 20,000 pounds. We changed that to kilograms. How many kilograms did we get, Will, for the boulder? Oh, no.
I think it's
6,000 kilograms?
6,000 kilograms.
Okay, so we take 6,000 kilograms. And so how many meters did we say it probably went?
5.
5 meters? Okay, so we're doing 5 meters times how many kilograms?
Times
Go ahead and show that.
6,000 kilograms times 9.8 times 5 equals
294,000
joules.
Joules. Okay, so if the boulder lands on him, that's how many joules of suffering he'll get. Okay, Will, when he falls off a cliff, what's the math for him falling off a cliff? Okay, if he falls, he's 15 kilograms.
Yes,
Times
75 meters
meters.
times 9.8
Times 9.8.
equals 11,025.
So what's worse, falling off the 75-foot cliff or the 10-ton boulder landing on your head?
10-ton boulder.
Read this to me, Lauren.
Okay, so
Read the whole thing.
what do coyotes, pumpkins, roadrunners, and fire trucks have in common? They all help us with physics. Today we are dropping a pumpkin from a fire truck ladder that is 15 meters high. We have to build a box that will help it not explode. So our box will absorb 558 joules.
Okay, so how'd you get 558?
First, we found the mass of the pumpkin. It weighed 8.5 pounds. We changed the pounds to kilograms by multiplying it by
Yeah. 4.5.
multiplying it by 4.5.
Oh, 0.45.
0.45.
Okay.
We got
3.8.
3.8 kilograms. The ladder is 15 meters long. We learned that you multiply mass times height
Times 9.8.
times 9.8, and then you get how many joules it is.
So it's 558. So your box has to do that. Now, how did we use the Coyote in the cliffs to do that?
Well, we so this one is the coyote falling off the cliff, and the cliff is 75 meters.
We just made that up.
Yeah. We guessed that it was about like 75 meters high. And then the coyote weighed
45 pounds.
45 pounds, and then we had to change that into kilograms, which is 15 kilograms. And then the 9.8 was
Just from the formula.
yeah,
Okay.
just from the formula, and then we had to multiply it all together, and it equaled 11,025 joules.
No, that's different from when a boulder falls on them, right?
Yeah. With the boulder, it would hurt a lot more. So it's 6,000 kilograms times 5.
5 meters in the air, right?
Yeah, that's what we guessed. And then a 9.5, I mean not 9.5, 9.8 from the formula, and then it equals 294,000 joules.
Nice.
So it would hurt a lot more.